The increased use of performance project recognised that FV4.1 was potentially preventing innovation by limiting visibility in an emergency to that provided by the lighting only. So the ABCB changed lighting to visibility to enable other systems. As you can see, the title of Part E4 has also been changed accordingly. A new subclause A has been included to require sufficient visibility of exits and paths of travel to an exit in lieu of a level of illumination. A new subclause B has been included to require a system used to provide a sufficient visibility in A to activate instantaneously upon the failure of an artificial lighting system. Consequently, the existing subclause have been renumbered. Ventilation. The new verification method is ventilation. The performance requirement to which this verification method applies is FP4 in Volume 1. This performance requirement is about ventilating a space within a building so that the acceptable indoor air quality is achieved. In quantifying this performance requirement, the ABCB has nominated the maximum containment level permitted in table FV4.1. This table lists the pollutant, the maximum amount allowed, and the period of time over which to measure that pollutant. So, for example, right now, we're all breathing out carbon dioxide, which is the first row of the table. As measured over 8 hours, under this verification method, a room cannot contain more than 850 parts per million of carbon dioxide, and fresh air is to be introduced at a rate which enables that. In Volume 1, the table applies to Class 2, 3, 5, 6, 9B and 9C buildings and Class 4 parts of a building. So no factories, laboratories or healthcare buildings are applicable for this verification method. In Volume 1, Table FV1 sets out maximum carbon monoxide exposure for car parks. You'll notice that the values are higher than those set out in the first table, which recognises the fact that car parks are generally not occupied for long periods and it is acceptable to have a higher containment level. Like the first table, the contaminant levels are measured over a period of time which allows for a higher concentration in peak periods. Contaminant levels are relatively easy to monitor after construction. But what about at the design stage, which is when this verification method would be used? We are already rely upon computer modelling in fire engineering for smoke exhaust and occupant egress, and there is some excellent software available for that. There is also software already available for modelling contaminant levels. These screenshots are from one such software package. This can be used by an appropriate professional to demonstrate that a ventilation design complies with the new verification method. This new verification method allows a refined mechanical design tailored especially for a given building. Engineers can use computer modelling to come up with an innovative solution which will reduce cost and energy consumption. F5.4 contains requirements for sound insulation for floors in Class 2 and 3 buildings. The provision is separated into airborne noise, for example, the stereo in the unit above you, and impact noise, which could be footsteps in the unit above you. The impact provision included a spectrum adaptation term, CI, which has now been deleted. CI is supposed to make an adjustment for high-frequency noises, like footsteps on a hard surface. However, research indicates that it doesn't assist in practice, so it has been deleted. This brings Australia in line with international sound insulation provisions. Verification method FV5.1 has been adjusted in the same way.